Okay, so now we're doing page 11-12 of logic. Use truth table to determine whether P and Q and R is equivalent to P and Q and R. So the first thing we're going to do is we are going to make three columns with our inputs, P, Q, and R. And the important thing is that we have every single combination shown here. And the most organized way that you might do it is to put half true, half false. Then you do a quarter true, quarter false, quarter true, quarter false. And then in the last R column, you do true, false, true, false, true, false, true, false, alternating. And now you're guaranteed that you have every single combination. Okay. And then, let's see. We are going to combine the first two columns, P and Q, for this here. We need to have P and Q, right? So P and Q would be combining this column and, oops, and this column. So if we ever have two trues, then it's true. Otherwise, it's false. So just the double trues are going to be true. And those are the only two double trues. Everything else is false, right? False, 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 false. I got an idea. Why don't I do like green and red to show true and false? Maybe that's better. Then the next thing we need is P and Q, and then we're going to OR that with R. So we're going to OR this with R. Okay, so it'll be P and Q or R. All right, so that is going to be this ORed with this, okay? And when you OR these together, that means that anything with true in it is going to be true. So if there's any true, like there's a true, there's a true, there's a true, there's a double false, so it's not. There we go. So those are all the truths, and the rest of them are false. Okay? So that is the answer for the left side. So that's the left side. Now we're going to construct the right side. The right side, the first thing we need is Q and R. So we'll do a Q and R. Q and R. So Q and R is formed by combining this column with the R column with an and. And so only the when you have a double true is a true. Everything else is a false. So there's a double true. There's a double true. And that's it. Okay? All right. And then we find we're going to AND that with a P. We're going to AND this with P. Okay. So we're going to have this ANDed with P. So we're going to AND the two yellows together. When you AND things, you're looking for double trues. When you have double trues, it's true. Otherwise, it's false. So there's a double true. And there, no. And that's it. That's the only double true. Everything else is false. False, 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 false. So this is the right side. And now we're going to check, are they equivalent? And so we're going to compare, this with this column. And no, they're not anything alike. So, no, they're not. So that means that not equivalent, okay, not equivalent. And if these are not equivalent, then are brackets important? Yes, they are. Brackets are very important in logic, just like they are in math. Maybe even more so, because there's not so many cases where the order doesn't matter. Number 3, use Venn diagrams and the sets P, Q, and R to show that P union Q union R and P union Q union R are equivalent. Okay, so we're going to use Venn diagrams. Think back to Venn diagrams. So let's give color codes to this. P would be blue, Q would be purple, and R is going to be brown. Okay, and let's see. So P or Q is going to be, I don't think we need color codes. P or Q is going to be this figure 8 shaped here. Okay, that's P or Q. Then we're going to union that with R. So we're going to add R to it, and then we just have like everything, right? So the everything in here is included. Okay? And then we're going to do the opposite. We're going to do Q union R first. Q union R would be this region here, and then we're going to union it with P. And you see how they're both just like everything, okay? So that's interesting because when you use the logical operators here, you can see that order matters. But when you do union here in sets, it does not. Of course, we didn't do the equivalent. We didn't do intersection, so we can't say anything, right? Number 5. Use Venn diagrams and the sets PQR to determine whether P intersect Q or union R and P intersect Q union R equivalent. I would guess no, but we'll see. So let's see. Q union R is going to be Q union R. It's this space here. And then we're going to intersect it with P. So then it would only be this part here. Okay, so that's that, right? Then we're going to do P intersect Q, which would be just this fish-shaped thing here, P intersect Q. And then we're going to union that with R. Union with R includes all this area. So yeah, those are not equivalent at all. Not. Okay? All right. Now we're going to use Venn diagrams and the sets P, Q, and R to determine whether P union Q intersect R and P union Q intersect R are equivalent. So first thing we're going to do is Q intersect R. So Q intersect R is that fish-shaped thing there. And then I'm going to union that with P. And so I'm going to add that, and then I'm going to get that. Then I do P union Q, and that'll be like this snowman-shaped one here. And then I intersect with R, and then I get that. Okay? So yeah, those are not equivalent. Not equivalent. Okay. Page 12. A compound statement that includes implication is called an argument. Okay? Implication is a one-way arrow. Do you see that one-way arrow? So it means something causes something else. Remember in our investigation, when certain conditions were satisfied, I commanded your score to be multiplied by 2, or taken the negative of, or add 3, or whatever, remember? So the implication is going to cause you to do something. Okay? So when they're both true, then that means the implication is true. So that means that yes, P did imply that Q was also true. Now, if P is true and Q is false, then no, that the implication didn't work, right? P was true, but Q was false. Now, if P was false, actually it doesn't mean anything as far as true, because if P is false, the arrow doesn't do anything, right? So this could be true. It could be true that Q is true when P is false. And then when P is false and Q is false, that could also be true. So you can see that like if P is false, anything goes for Q. Q could be true, Q could be false. So these are valid. And so this is valid and these are valid, but this is not valid. When P is true, Q cannot be false because P implies Q means that if P is true, then it forces Q also to be true. Okay? So that's just explaining that. Now we're going to use truth tables to analyze the arguments. P implies P and Q, and P implies P or Q. So we are going to put P here, and we're going to put Q here, and we're going to put all the different combinations, which are true, 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 false, false, true, and false, false. And so first we're going to just find out what about P and Q. What's P and Q equal to? P and Q. So P and Q is true whenever you get a double true, and otherwise it's false. Okay? And then we check. Okay, now we're going to do implication. We're going to say P implies P and Q, right? Yeah. And so let's see if that's true. So we're going to compare this with this. Okay, so when P is true, that implies that P and Q is true, so that's true. But wait a second, when P is true, P and Q is false, so that would be false. Okay, and then when P is false, those are fine. When P is false, anything goes. Okay, then now we have P implies P or Q. So we're gonna find P or Q. P or Q, we're gonna compare this one and this one, and when we do that, we want to, whenever we have any true, one or two trues, it's always going to be true. So we'll have true, 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 and the last one is going to be false. And then we say, does P imply P or Q? So does P imply P or Q? So true leads to true, that's true. True leads to true, that's true. False leads to true, yeah, that's possible. And false leads to false. Yeah, that's possible. Okay, so the implication P implies P or Q. That is a tautology. Okay, so yes, this one is true. Okay, this one is not. All right, use the truth table to analyze the arguments. P or Q, or P or Q implies P. And P implies P and Q. Ooh. See, these like make no sense. You just need to do the truth tables and see if they are true or not, okay? When you read them, unless you're a lot better at reading these logic sentences and understanding than I am, makes no sense. Okay, that's why it's so important to make these truth tables. After analyzing, I don't know why I put two tables here, so I'm just going to make one table, okay? And I'm going to have true, 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 false, false, true, false, false for the input. And then I made two columns, one for P or Q and the other one for P and Q, because I know I need both for these, right? And then now I'm going to do a P or Q implies P column, and then I'm also going to make a P implies P and Q column. Okay, so we're going to do these two columns. Let's see. First of all, we're going to say, okay, so P or Q implies P. Okay, is that true? So let's see. True and true is true. True and true is true. True and false is, oh, that's false. False and false is, that's fine. False and false can be true. Okay. And then the next column, does P imply P and Q? So that means we're looking at, does P imply P and Q? Okay, now does P imply P and Q? So P and Q is this one, P is this one. So does P imply that? So does true imply true? Yes, that's good. True imply false? No, true cannot imply false. True always implies true, so that's false. Does false imply false? Well, if P is false, then P and Q could be anything. So these two are perfectly fine. They're true. Because if P is false, then Q can be anything. So those are fine. Those are valid. All right. And then, so what we're doing now is we're going to and these two together. we're going to and this and this together, right? Because that's that one and that's that one. Okay, so when we and these together, we're just going to get true, false, false, true. So that's what we get when we and both together. Okay, so sometimes it's true and sometimes it's false. Okay, it's not a tautology or anything. Okay, number 5. Oh, now I see why I put 2. So I'm going to use this table for that one, and I'm going to use this table for that one. Use the truth table to analyze the argument. P and Q implies P. Or with P implies P and Q. Whew. Okay. First thing I'm going to do is I'm going to copy and paste some of these things because we're going to recycle them. Okay, so we need this one, right? So copy, and then we'll do paste. Okay, that's one of the things we need. We also need a P and Q, which I have one right here. P and Q. Right there. Copy, paste. Okay. And then we also need and that's pretty much it, right? Maybe we need a P implies P and Q, because we had one up there. We'll copy this too. Copy, paste. Okay. Anything else we need? P and Q implies P. P and Q implies P. Okay. That's very similar to that one, isn't it? So the last thing we need then is this one. P and Q implies P. Okay. So to analyze P and Q implies P, we're going to, let's see, P and Q would be this, implies P would be that. So the question is, does P and Q, let's see, true goes to true. True implies true, that's true. False implies true, that's true. When it's false, it can be anything. And the rest of them are all false, so they can be true. Hey, look, it's a tautology. Okay, and then the final thing we're going to do is we're going to union this together with this, because you see how at the very end we're going to union both together? Or not union, but we're going to and them together. So the double trues are true and everything else is false. So there's double true, and this is a false. So this is not a tautology, right? So the result is this one here. Okay. All right. Now let's do the last one. So we'll copy and paste this. Okay, so we have our little table of trues and falses. And then we're going to need P and Q. So P and Q would be P and Q. Let's see. There we go. And then we're going to see if that implies not P or not Q. So we're going to need a not P column. We're going to need a not Q column. We'll need a not P or not Q column. Okay, and then we'll see if it implies it. We're going to have to erase that because it's in the way. Okay, so not P is basically false, false, true, true. Not Q is basically false, true, false, true. And not P and not Q is going to be, and when we have any truths, we just make it true. So there's a true, there's a true, there's a true, and there is no true. Okay. And then last of all, we're going to see if the implication, if this, oh, there's a not, oh, and there's another one here. We need a not P and Q. So that would be not P and Q. So not P and Q would just be the not of that. So it would be false, true, true, true. False, true, true, true. False, true, true, true. False, true, true, true. Okay. So now the question is, for implication, does not P and Q imply not P or not Q? And let's see. Looking in this direction, from right to left. So false implies false. That's fine. That's valid. True implies true. That's true. True implies true. That's true. And true implies true. That's true. Oh, look, it's a tautology. Okay. Yeah, so yes, this is okay. All right. And this one was not okay, right? Okay. Well, it's not tautology anyway. This one is a tautology. This one is not. It's neither. Neither tautology nor a contradiction. Okay, and I think that that is the end of this sheet.